You know, the internet, it really does feel like magic, doesn't it? You click something and boom, a whole universe of information just appears. But here's the thing. Behind that screen, it's not magic at all. It's actually this incredibly organized, super structured system. And today, we're going to pull back the curtain on one of the most critical parts of that system, the transport layer. All right, so here's what we've got on tap. First, we'll talk about the internet's postal service. Then we'll get into the transport layer's job. After that, it's TCP versus UDP, choosing your career. We'll also peek at the anatomy of a packet, and finally, we'll follow your click's journey. Let's dive in. Okay, Section 1, the Internet's postal service. So to really wrap our heads around all this, I want you to imagine the entire internet as just one giant global postal service. I mean, at its core, that's what it is, right? A system built to get messages from point A to point B as reliably and efficiently as possible. So have you ever really stopped to think about this? How can your one single internet connection handle your game, a video call, and your browsing the web all at the same time? I mean, you've probably been there, right? The laptop's on a Zoom call, your phone scrolling Instagram, the Xbox is downloading a massive update. How on earth does your computer keep all of that data from becoming one giant jumbled mess? Well, the answer is in this crucial and honestly kind of overlooked part of the network. And that's where the transport layer comes in. Just think of it like the internet's master sorting office. Your computer is basically a huge office building, right? It has one mailing address. That's your IP address. But when a bunch of mail arrives, somebody has to sort it. You can't have the invoices for accounting ending up with the creative team. The transport layer is that digital mailroom clerk. It's the one making sure the data for your video call actually goes to Zoom, and the data for your web browsing gets routed to Chrome. It's the ultimate organizer. All right, Section 2, the transport layer's job. So what exactly is this digital sorting office doing all day? Well, it turns out it has a few absolutely critical responsibilities that honestly make our entire modern internet experience even possible. Let's break these down. First up, end-to-end delivery and multiplexing. That's the core sorting job we talked about, getting the right data to the right app and letting all those apps share one connection. Then you've got segmentation and reassembly. This is all about efficiency. You can't just send a whole movie file across the internet in one giant chunk, so it gets chopped up into thousands of tiny, manageable little packets and reassembled on the other side. And finally, reliability. This is like quality control, making sure that none of those little packets get lost or messed up on their journey. It all has to work together perfectly. So how does it actually know where to deliver all this data? The secret is something called a port number. Okay, so if your computer's IP address is the street address for the building, the port number is the specific apartment number. It's that simple. For instance, when you go to a secure website, your browser is sending data to a very specific port on the server, port 443. That port is like the penthouse suite reserved exclusively for HTTPS traffic. It's this really elegant, beautifully simple addressing system that makes all of that multitasking, that multiplexing even work. Okay, moving on to Section 3, TCP versus UDP, or choosing a courier. Because, let's be real, not all data is created equal. Sometimes you're sending a super important legal document that absolutely has to get there, and sometimes you're just firing off a quick postcard. To handle these different needs, the transport layer gives us two main courier services, TCP and UDP. So let's look at the difference. On one side, you have TCP, the Transmission Control Protocol. Think of this as your certified mail service. It's super reliable. It actually sets up a connection before sending anything. You might have heard of the three-way handshake. It's kind of like a digital ready, set, go. It numbers every single packet, it checks for errors, and it demands a confirmation receipt for every piece it sends. Perfect for email or browsing, right? You want to know for sure that your message got there. But all that checking, well, it slows things down. Then you've got UDP, the User Datagram Protocol. This is your postcard. You just write it, you send it, no connection, no confirmations, no guarantees. It's way, way faster, which is exactly what you want for things like live video streaming or online gaming. I mean, if you lose one single frame of a video, who cares? The next one is already there. Speed is the name of the game. All right, Section 4, Anatomy of a Packet. Let's geek out a little and zoom in on that certified mail, the TCP packet. Every single one has this incredibly detailed header that's basically a digital shipping label with all the info needed to make sure it gets where it's going. Okay, so let's really break down what's on this shipping label. You've got the source and destination ports. That's the from and to apartment numbers. Simple enough. Then there's the sequence number. This is like meticulously writing page 1 of 10, page 2 of 10, and so on, so the receiver knows exactly how to put the message back together. The acknowledgement number is the receiver sending back a little note saying, hey, I got page 1, send the next one. The flags are for managing the connection, kind of like saying hello, goodbye, or hang on a second. And the checksum, that's just a little bit of math to double check that the package wasn't damaged in transit. It's this amazingly detailed and structured system, all designed for one thing: total reliability. Okay, section 5, your clicks journey. This is where it all comes together. We are going to follow a single click from your browser and watch as it gets packaged up layer by layer and sent out into the wild. This whole process has a name. It's called encapsulation. So it starts with you. You type google.com. Your browser creates that HTTP request. That's your message, the letter you want to send. Then the transport layer kicks in. It wraps your letter in a TCP envelope and writes the port numbers on it. Next, the network layer takes that envelope and puts it inside a shipping box, slapping on the final destination IP address. Then, the data link layer adds one more label, but this one's just for the very next stop, your local router. And finally, the physical layer turns the whole thing into electrical signals or radio waves to send it on its way. It's like a set of Russian nesting dolls where each layer adds its own wrapper without ever looking at what's inside. So this layered addressing system is absolutely key to the whole operation. You've got 3 different kinds of addresses working together. The MAC address, that's just for the next hop. It's like telling the mail carrier, just get this to the local post office on the corner. The IP address is the big picture, the final destination building, the city and street address. And the port number? That's the most specific instruction of all. It's the deliver to apartment 443 part of the address. This cascade of precision is what guides your data perfectly at every single step. And really, that's what it all boils down to. The internet itself, it's a huge, messy, chaotic collection of different networks. The transport layer is that unsung hero. It's the disciplined, structured process that sits on top of all that chaos, bringing order and reliability and letting our apps talk to each other without a problem. It's the manager that makes the whole show run. So the next time you're just browsing a website or you hop on a video call, just take a second to remember this incredible, intricate postal service working tirelessly behind the scenes. Your data's journey is a true cascade of precision, a masterpiece of structured design. And it kind of makes you wonder, right? What other hidden, elegant structures are powering your digital life right at this very moment?